All right, we're working on free response questions with graphs of f prime. All right, and so this is a common type of problem. Now there's lots of ways these problems can go, but they all kind of have a graph that represents some kind of derivative. So, in this assignment by the AP board. So. I want to go through here just to kind of talk through a few and clear up any confusions here, and even though the answers are on the next page there. So this problem right here, this first one from 2018, we've got a function, it's g, we've got the derivative, it's a derivative of f. Really useful the moment you see that right here, the moment we see that g is the derivative of f of x, write that down. G is f prime of x. Just write it down. This is f prime, all right? And just keep that in mind. And as we look through, we know a few things. It's linear, piecewise for part of it, and then we have the function here, which makes me think that we're going to be finding the integral or derivative in this region here. All right, so let's kind of go through here, and we're looking for clues, word clues that make us think about what we need to do. So here we've got f of 1 is 3 and find f of negative 5. So we got 2 points. Now, we know that g is the derivative of f. We can also say this the other way, that the integral of g of x is f of x. All right, it's the antiderivative. So that's useful also. These are saying the same thing. And when we're looking for values, we often should be thinking about FTC 1. All right, the fundamental theorem of calculus 1. And the reason for that is we've got an integral from negative 5 to 1 of g of x. Well, that's going to be the antiderivative of g is f. And so fundamental theorem of calculus says we take the antiderivative f of x, and we're going to go from negative 5 to 1. And probably skip that step of what I just wrote there, but that's just f of 1 minus f of negative 5. All right? So when we have things that are integrals or derivatives of each other, vice versa there, and we're looking for two values or we know one, then that's what we're going for. Now, so how does that help us? Well, we know some of these things. I'm going to highlight the things we know. We know this. We know this. We don't know f of negative 5. So we can compute this. Well, you might say, how do we know that integral? Well, we know the integral because an integral is area. And so from 1 to negative 5, we can look at that here. And so from 1 to negative 5, we've got this area here, and we've got this area here. All right? So this little triangle over here, right there. That triangle has an area of 1. And then we got this trapezoid thing over here. That has an area of 9 here. And that's going to be 1.5. Okay, so area of a triangle is 1/2 base times height, 1 times 3. Okay, so that's 1.5. So this is going to be 9.5 negative. So the integral, if we add those, the area, oh, and by the way, this little line has no area between it and the x-axis. So if we add those two, we get negative 8.5. So this is negative 8.5. And we also know f of 1. So f of 1 is 3. That was told to us. And we don't know f of negative 5. So you see that there? All right. If we add f of negative 5 to both sides and add this guy over here, then we're going to find out that f of negative 5 is 12.5. All right, or 25 halves. Okay? That's the idea there. All right, so that's the clue there. We know that they're integrals. One is an integral of another, and in writing this out, both of these relationships going to be real helpful to see that. That will help you to jump to this idea here. All right, cool. So evaluate this integral now. All right, so this is pretty straightforward. Integral is area, but what we need to do is we need to break it up because we're told here that it's linear, which means we can just find the area easily, like we just did for part of it. But then, and that's from -5 to 3. But then we've got this part of it from 3 to 6. We got to break this up, and this is something that they'll be looking for. And if you look at the scoring guidelines, you'll see this kind of thing from 1 to 6 g of x. Dx, and we got to break that up. So we have this rule that says that we can break up integrals and the sum of two integrals, that is equal to their total. All right, so g of x dx. And so that notation right there, that will get you points. You'll notice that right there is 1 point just for writing that. If you did nothing else, you get 1 point, all right? And then we can rewrite this as, gonna run out of room here. And you can look at the instructions or the answers on this, but we can look, let's erase that. We can look at the area here, and the area of this is just 4. All right, we don't need to show anything fancy for that. The area is 4. And then this is the integral of 3 to 6 of 2 times x minus 4 cubed dx. All right, dot, dot, dot. And I'll let you look at the instructions. You get a point for finding that antiderivative, and that's going to be, in the end, is going to be 10. All right? Okay, good. The point being, notice that right here, this is a clue that they're going to want to see this. It's going to have to be broken up, and we have to attack it in 2 different ways because there's different parts. All right? All right, let's look at some strategies for the next part. All right. The question is, on what open interval, if any, does a graph both increasing and concave up? Give a reason from your answer. All right. This is a great situation for number lines. All right. And we want, by the way, this is the graph of f, not g. Don't get confused there. We're looking for f. All right. So, concave up, you should be thinking about f double prime. Increasing, you should be thinking about f prime, the first derivative. And we can get both of those from the graph. Now, you won't see this number line on the solutions there. However, that's a great way to go. And a number line says everything. That is your reasoning. And so you don't have to explain anything much in words, all right? But f prime, this is f prime. Notice we put that up here. This is why we wrote this, because you should be saying to yourself now, I got to find f prime. Okay, well, let's find f prime. All right, found it. This is the graph of f prime. Wherever the line is, that's f prime. And we see that it's negative from 0 to -1, all right? So let's see. Our zeros, let's start with our zeros. Our zeros at -1, 0, and 4, all right? So we're at -1, 0, and 4. And to the left of -1, it's negative. From -1 to 0, it is 0. That's kind of weird, but that's the way it is. It's positive between 0 and 4, and it's positive from 4 to infinity. And then how do we find second derivative? Well, second derivative is the slope of the first derivative, right? Okay, and so where does the slope change? The slope changes at -2. The slope changes at -1. The slope changes at 0. The slope changes at 1. Slope changes at 3. And then at 4. Okay. So what's going on here? Okay, so we're looking at the slope. The slope is 0 here, positive, 0, positive, 0, negative, positive. All right, the derivative that is. So we've got, let's see if we can get all that in there. I'm doing blue here. 0, it was positive, it was 0, it was positive, it was 0. And you can look back at your graph to see that. Negative, and then positive. All right, so the question is this. Now, when is it both increasing and concave up? Well, here's concave up, but this goes with this section. Notice I tried to line up the negative ones. That's helpful. This is 0 and 0, okay? This is concave up, and increasing. There it is. So we've got a little section right in here that's both positive and positive. All right, and so that's from 0 to 1. There's our first answer. And then we're looking for another concave up. Here's another concave up section, and that's from 4 to infinity, and that's also increasing. That's positive, and so we can say from 4 to infinity. Now, you'd probably be just fine with that number line, those number lines there, but it's a good idea to say, and in fact, maybe we should have even said this before, increasing and concave up, we should have written this down, what we were looking for. F prime of x increasing, that means f prime of x is greater than 0. Concave up, that means f double prime of x is greater than 0. Okay? Now, by the way, when they say give a reason, it doesn't mean necessarily you need to write a lot of words. Okay, symbols are great. That's what they're looking for. Okay, they're looking for those key points. All right, one more. Find the x-coordinate of each point of the inflection point of the graph. Okay, so we know that inflection point, so right away, once you see inflection point, we should be saying f double prime of x is 0. That's a possible inflection point. So before you even look at anything, think of anything. When you see inflection point, write this down. In the same way, I wasn't a good example here, but in the same way, once you see the word increasing, you should write this down. Once you see the word concave up, you should write this down. It is very likely that that'll earn you points, even if you do nothing else. All right. If you're stuck, you run out of time. If you see the word increasing, you write f prime of x is greater than 0. Concave up, f double prime is greater than 0. You're golden. Points. Money in the bank. Inflection, we want f double prime equal to 0. Well, we have that here. Okay, and by the way, this work kind of will often earn you points here. So sometimes they will look back there. So, but this is our reason here, okay? And so, and that happens at, where does double prime equal 0? Well, we have 0 at several points, but we don't have positive and negative on both, all right? So here we have, at 4, we have a 0. We got zeros here, okay? But we need the concavity to change from negative to positive. So here, at these points, the concavity is not changing. It's going from 0 to positive or 0 to negative. That doesn't make inflection, okay? So we can say at x equals 4, the concavity changes, or f double prime of x goes from negative to positive. All right, something like that, and they say it similar way. They say the f prime goes from decreasing to increasing, so that's the idea. All right, cool. Well, there's some things to think about, all right? And as we go through that problem, we see some important things. Again, right, see an increasing, writing this down. Seeing concave up, writing this down. If you look in the scoring guidelines, you'll see that there's points for that, all right? And this look for this FTC1 when you know that there's a relationship of an integral or a derivative, and vice versa there, and we're looking for 1 point, and we know 1 point, that's likely going to be fundamental theorem of calculus. All right, very common stuff. So great. All right, well, we'll leave it at that, and hopefully that gives you something to go off of there. But do study those scoring guidelines and notice what points are given for.